need to test FastMCP authentication locally without exposing real credentials or setting up a full identity provider. We'll generate a temporary RSA key pair, create signed test tokens with proper issuer and audience claims, and configure a verifier that matches exactly, all while keeping credentials contained to your development environment. This pattern gives you a safe sandbox for testing authentication flows before moving to production-grade solutions like JWKS endpoints or OAuth introspection. From FastMCP, server, auth, providers, JWT import JWT verifier RSA key pair. Hash generate a key pair for testing. Key pair equals RSA key pair. Generate. Hash configure your server with the public key. Verifier equals JWT verifier. Public key equals key pair. Public key. Issuer equals https://test yourcompany.com. Audience equals testmcp server. Hash generate a test token using the private key. Test token equals key pair create token. Subject equals test user 123. Issuer equals https://test yourcompany.com. Audience equals testmcp server. Scopes equals read, write, admin. Printf test token, test token. This demonstrates a development time pattern for JWT authentication using self-contained RSA key pairs, specifically designed for testing environments. The code creates an ephemeral key pair where the private key signs test tokens and the public key verifies them, with all claims, issuer, audience, scopes explicitly configured in code. Unlike production systems that use external authorization servers, this approach generates everything locally for controlled testing. The pattern works by establishing a closed verification loop within a single process, where the same code that creates tokens also configures their validation rules. This eliminates external dependencies during development while maintaining the core JWT validation flow: signature verification, claim matching, and scope checking. The explicit audience and issuer matching enforces that tokens can't be accidentally reused across different test services. This approach matters for safe development iteration, but carries critical security limitations. Printing tokens to console and using fixed keys is explicitly unsafe. For production real systems should use JWKS endpoints or OAuth introspection. The pattern's value lies in enabling rapid testing of authentication flows before integrating with production-grade identity providers, where you'd replace this with proper authorization, server integration, and never expose keys or tokens in logs. Let's break it down. From FastMCP, server, auth, providers, JWT import JWT verifier RSA key pair. Imports JWT verifier for stateless JWT validation and RSA key pair for development-only key generation. This pattern creates self-contained test credentials, but is unsafe for production. Never use fixed keys or print tokens to console in live environments. For production, use JWKS endpoints or OAuth 2 introspection instead. Hash generate a key pair for testing. Key pair equals RSA key pair. Generate. This generates a development-only RSA key pair for JWT testing. The RSA key pair generate method creates self-signed public-private keys. Never use this in production, as real systems require proper key rotation via JWKS endpoints or authorization servers. This pattern demonstrates minimal viable auth setup, but note that printing tokens to console creates security risks in live environments. Verifier equals JWT verifier. Public key equals key pair. Public key. This creates a JWT verifier using the public key for development testing only. The public key validates token signatures without exposing the private key, but note this is a simplified pattern. Production systems should use JWKS endpoints or OAuth 2 introspection. Never print tokens to console in production, as this example does for demonstration.
Test token equals key pair create token. Subject equals test user 123.
This creates a test JWT with test user 123 as the subject claim, identifying the token holder. Critical security note: RSA key pair generate is for development only, never use fixed keys in production. In real deployments, use JWKS endpoints or OAuth 2 introspection instead.
Printf test token.
This prints the generated JWT to console for inspection during development, but never use this in production. The RSA key pair pattern here is strictly for testing. Real systems should use JWKS endpoints or OAuth 2 introspection. Always verify that issuer and audience claims match exactly between token creation and verification. JWT testing pattern. FastMCP's RSA key pair generation provides a self-contained authentication system for development, where private keys sign tokens and public keys verify them without shared secrets. This pattern uses fixed keys for testing only. Never expose private keys or print tokens to console in production environments. The issuer and audience claims must match exactly between token creation and verification, or validation fails silently.
The test key that proves everything secures nothing, while the production key that secures everything proves nothing by itself.